Hi there, welcome to the another session of chemistry. Today I am here with the chapter number 5, electrolysis. So let's get started. At the end of this part of the video, you should be able to define the basic terminologies used in electrolysis, differentiate between strong and weak electrolytes with example, and then describe the mechanism of electrolysis. The word electrolysis is derived from two words, namely electro, meaning current or electrons flow, and lysis, which means decomposition or breakdown. Combining the two words, we can define electrolysis as the chemical decomposition of the compound by passing direct current through its molten state or aqueous solution. The setup for electrolysis is known as an electrolytic cell or voltmeter and consists of electrodes, electrolyte and power supply with connecting wires. A lamp is at times added to ensure that the connections are correct. An electrolyte is a substance that allows current to pass through it in its molten state or aqueous solution and gets decomposed in the process. It is divided into strong and weak electrolytes. A strong electrolyte ionizes completely in solution. Examples are strong acids such as tetraoxosulfate acid, hydrochloric acid, trioxonitrate acid, etc. Strong alkalis like sodium hydroxide and hydroxides of the group 1 metals, and salts such as copper 2 chloride, sodium chloride, copper 2 oxosulfate, potassium bromide, lead 2 bromide, and so on and so forth. A weak electrolyte undergoes partial ionization or dissociation in solution. Examples are weak acids like ethanoic acid and other organic acids, and weak alkalis like aqueous ammonia as shown on the screen. The single forward arrow shows a reaction that goes to completion, while the double reversible arrows indicate an incomplete or partial reaction. Electrodes, on the other hand, are rods, plates, or wires through which current enters and leaves the electrolyte. They are the media through which electrons leave and enter the electrolyte. They are mostly metals except carbon graphite, which is a non-metal. Electrodes are generally divided into anode and cathode. Anode is the electrode connected to the positive terminal. It is the medium through which electrons leave the electrolyte, that is A for anode and A for away. It is where oxidation occurs during electrolysis. On the other hand, cathode is the electrode connected to the negative terminal of the battery, which makes it negatively charged. It is the medium through which electrons enter the electrolyte. Remember C for cathode and C for come in. Reduction occurs at the cathode. Next, let's look at the mechanism of electrolysis using sodium chloride. In the solid state, sodium chloride, being an electrovalent compound, is made up of aggregates of ions and cannot conduct electricity. But when it is melted by heating or dissolved in water, it undergoes dissociation to form randomly moving charged particles which are able to transfer electric charges from one point to another. When the electrodes are connected to the power supply, the ions migrate based on the law of electrostatic attraction. The negatively charged ions which migrate to the anode are called anode ions, shortened as anions, while the positively charged ions which move to the cathode are called cathode ions and are shortened as cations at the anode. The chloride ions undergo oxidation by losing one electron each to form chlorine atoms. Two chlorine atoms combine to form a chlorine molecule, liberated at the anode as a greenish yellow gas. The electrons lost flow through the connecting wires from the anode to the cathode and lights up the lamp in the process, confirming the electrolyte as a conductor of electricity. At the cathode, the sodium ions undergo reduction by gaining the electrons to become deposited as sodium metal. According to the cathodic half equation, in order to balance the number of moles of electrons transferred, we multiply the anodic half equation by and the cathodic half equation by 2, and then add the two equations and net of the number of moles of electrons lost and gained to obtain overall reaction. That is basically the mechanism of electrolysis. Note that this explanation is based on the electrolysis of molten sodium chloride, in which there are only two ions, sodium ion and chloride ion, in the electrolyte, and there are no competitions at the electrode. In the further part of the video, we'll be looking at what happens when there are more than two ions in the electrolyte. In this part of the video, we are going to look at how to differentiate between dissociation and ionization in water. We can easily differentiate between dissociation from ionization using two key points. Dissociation is the process that involves ionic compounds which obviously contain ionic bonds. Ionic bond, as we know, it is formed from the attraction between cations and anions, which are positively charged ion and negatively charged ion. Take NaCl for example. It is an ionic compound that is made up of Na plus ion and Cl minus ions. The attraction between Na plus and Cl minus ions form the ionic bond when NaCl is added to water. It separates into its existing ions, which are Na plus and Cl minus ions. Water molecules will orient themselves accordingly to surround these Na plus cation and Cl minus anion. Ionization, on the other hand, involves covalent bond. Take hydrochloric acid for example. It's a covalent compound where the atoms are connected through a covalent bond, meaning the electrons between the hydrogen and chlorine are shared. However, when it's placed in water, the covalent bond between H and Cl in hydrochloric acid will break to produce new ions, which are hydrogen ion H+, which is also called proton, and chloride ions Cl- ions. These ions did not exist prior to ionization. Therefore, when differentiating between dissociation and ionization, the first thing to do is to identify the type of bonds or the type of compound that's present. Also, if analyze the word dissociation, it means to dissociate, meaning split into separate parts. Ionization, on the other hand, means to ionize, converting into ions. Hope that clarifies the difference between dissociation and ionization. In this part of the video, we are going to learn about electrochemical series, what it is, and how it is used. We know that the different combinations of metals produce different voltages, and this depends on how strongly the metal could force its electrons to move across a cell. The electrochemical series is a list of metals and other substances arranged in ranked order of how easily that atoms may lose electrons. The further apart the metals are in the electrochemical series, the higher the voltage is produced across the cell. Electrons flow along the wire from the metal higher in the electrochemical series to the metal lower down the series. Electropotentials are arranged in the substance's ability to donate its electrons, that is, how easily they are oxidized. All of the values are measured in volts. What do you notice about hydrogen voltage, and what is the significance of this? Hydrogen has an electrode potential of 0 volts. The significance of this is that it acts as a reference. All other electrode potentials are measured against this value. Using electrochemical series, can you predict the direction that the electrons will travel towards for the following pairs of metals? the electrons always move from the metal with the more negative electrode potential to the more positive electrode potential. Now pause the video and continue and ready for an answer. The answer is that electrons move from potassium to hydrogen for A, and B, the answer is electrons move from zinc to copper, and for C, the answer is the electrons move from lead to mercury. About metal in the electrochemical series is the one that always displaces the ions of the lower down metal. Metals lower down the series cannot displace more reactive metals from this solution. In summary, the electrochemical series contains electrode potential, which measured in volts, which are compared to hydrogen. The greater the difference between the two substances in the electrochemical series, the more readily the electrons move from the more reactive metal, that is the more negative value, to the less reactive metal, that is a more positive value. At the end of this lesson, you should be able to explain how the relative position of ions in the electrochemical series, concentration of ions in the electrolyte, and the nature of electrodes affect the preferential discharge of ions during electrolysis. First of all, what you understand by the term preferential discharge or selective discharge of ions? It is the tendency for a set of ions to be favored for discharge over competing ions at the electrode during electrolysis. The first factor to be considered is the relative position of ions in the electrochemical series. Here, ions lower in the series are preferentially discharged to the ones above them, all the factors remaining constant. Let's use electrolysis of dilute sodium chloride solution, which contains sodium ion and chloride ion, hydrogen ion and hydroxide ion as the case study. When connected to the power supply, the ions migrate to the oppositely charged electrodes based on the law of electrostatic attraction. At the anode, the chloride and hydroxide ions compete for discharge, but the hydroxide ion is preferentially discharged due to its lower reactivity and position in the electrochemical series. The ease of losing electrons increases down the series for anions as less energy is required by the ions to undergo oxidation or lose electrons. The hydroxide ions undergo oxidation by losing one electron each to form OH radical. Since OH cannot exit on its own, 4 moles of OH will combine to form 2 moles of water and 1 mole of oxygen gas as seen in the anodic half equation. At the cathode, the sodium and hydrogen ions compete for discharge. However, the hydrogen ion is always preferentially discharged due to its lower reactivity and position in the electrochemical series. The ease of gaining electrons increases down the series for cations as less energy is required to undergo reduction. The hydrogen ions undergo reduction by gaining one electron each to form hydrogen atom. Being a diatomic molecule, two hydrogen atoms combine to form a molecule of hydrogen gas liberated at the cathode. According to the cathodic half equation, to balance the number of moles of electrons transferred, multiply the anodic half equation by 1 and the cathodic half equation by 2. Add the two equations to get the overall cell reaction. Next is the concentration of ions in the electrolyte. Here's the ions of higher concentration are preferentially discharged to the ones of lower, provided the distance between them is not wide. Now, let's use the electrolysis of concentrated sodium chloride solution, also known as brine, as a case study. In brine, sodium ions and chloride ions are of higher concentration than hydrogen ions and hydroxide ions since there are more salt and water particles in the solution. At the anode, the chloride and hydroxide ions compete for discharge and chloride ions is preferentially discharged due to its higher concentration. The chloride ions undergo oxidation to form chlorine gas, liberated as a greenish yellow gas at the anode. At the cathode, Sodium ion and hydrogen ions compete for discharge. But sodium ion is not discharged despite its higher concentration. This is because its distance from the hydrogen ion in the electrochemical series is too wide or beyond the permitted gap. Hence, the first factor, position of ions in the electrochemical series, overrides. The hydrogen ion therefore undergoes reduction to form the gas at the what cathode. Combining the two half equations gives the overall cell reaction. The last factor is the nature of electrodes. Here we will be reclassifying electrodes based on reactivity into inert and active. An inert electrode is one that does not take part in the electrolytic process. It does not determine the ions discharged at the anode. Examples are graphite and platinum electrodes. An active electrode is an electrode that take parts in the electrolytic process and influences the ion that can be discharged. Examples are copper anode in copper 2 salt solution and silver anode in silver salt solution. By the end of this lesson, you should be able to describe the electrolysis of copper sulfate solution using inert or active. Explain the effect of electrolysis, copper sulfate solution using graphite electrodes, and finally, you should explain the effects of electrolysis on copper sulfate solution using copper electrodes. The electrolysis of copper sulfate is important in the study of electrochemistry, as it is the basis for the purification of copper and other less electropositive metals like silver, gold, platinum, etc. Copper sulfate made up of aggregates of copper sulfate ions ionize in water to form an electrolyte made up of copper 2 ions, sulfate ions, hydrogen ions, and hydroxide ions. The ions migrate to various electrodes based on the law of electrostatic attraction. You will really have to watch on the preferential discharge of ions to see how these ions migrate and get discharged at the electrodes under different conditions. As our emphasis is on the effects of electrolysis of aqueous copper 2 sulfate, so in the electrolysis of copper 2 sulfate using graphite electrodes, after the hydroxide ions are discharged at the anode as oxygen gas and copper 2 ions are discharged at the cathode as metallic copper deposits, as shown in the anodic half equations, the hydrogen ions and sulfate ions remaining in the solution combine to form tetraoxosulfate 6 acid, that's H2SO4, thereby increasing the acidity of the resulting solution and decreasing its pH. Also, the gradual removal of the copper 2 ions from the solution as metallic copper causes the blue color of the electrolyte to fade gradually, since the presence of the copper 2 ions in solution is responsible for its blue color. And finally, the deposition of the metallic copper at the cathode causes it to increase in size and mass. In the electrolysis of copper 2 sulfate using copper electrodes, there is no discharge of ions except copper 2 ions at the electrodes. This is due to the interference of the copper electrodes in the electrolytic process. So, the copper anode goes into the solution and replaces the copper 2 ion deposited at the cathode as metallic copper, as shown in the equations of reactions. At the end, there is no net change in the concentration and composition of ions present, so its color and pH remain the same. Also, the replacement of the copper 2 ions in the electrolyte by copper atoms from the anode causes the anode to decrease in size and mass, while the deposition of the metallic copper at the cathode makes it increase in size and mass. As stated at the beginning, the principle behind electrolysis of copper 2 sulfate solution using copper electrodes is applied in the purification of metals and electroplating. Hope these topics are clear to you all. We'll cover the remaining topics of the chapter in the next part of the video. Till then, take care, be safe and study properly.